one and the others?
Yep.
What form is okay?
Yeah.
So yeah, just as long, whatever the directions say. So if it matters to me whether it's point slope or slope intercept or standard form, I'll say.
Okay.
Otherwise, I'll accept anything. And so if it isn't specified, I would definitely go with point slope form, because I think that's going to be quicker and easier. And that's something that I'm going to kind of really nag you about there, because if it isn't currently in your toolkit, it needs to be, because that's the most efficient way to come up with an equation of a line. Good. Other questions? What would you like to see clarified? Okay, well, we're going to talk today about, this is section 1.5 in our book, and modeling with linear functions. Which essentially means that we're going to be trying to do some kind of word problems and stuff like that with it. But first, let's consider the system of equations. And again, taking you back to your Algebra 2 days, if we have something like y equals x minus 1 and y equals negative 2x plus 3. So we'll start with a system of equations here. And the natural question to ask, each of these represents a straight line. So the natural question to ask is, are they ever going to intersect? So will they intersect? And you can think on that for a moment. And of course, my follow-up question is going to be why, or how do you know that they're going to intersect or not intersect? Anybody willing to take a shot at that? Yes.
Well, they should intersect because they have different slopes, so they're not parallel.
Exactly. So the only way that these would not intersect is if they were parallel lines. And we know that parallel lines have equal slopes. Since these have different slopes, then yes, they must intersect. And because their slopes are different. Okay, so then the follow-up question there is, where do they intersect? And let's do this first just by, do I want to graph this? I don't think we need to here yet. How can we figure out where they intersect?
You can set them equal to each other.
Set them equal, yeah. So I think you learn, you call this equal values method or something like that. Since these are equal to each other, we can just substitute one of these things for y in for the other. So here we can say the negative 2x plus 3 is equal to x minus 1. And we can go anywhere we like with that. So I'm going to add the 2x to the other side just because, given the choice, I would prefer to keep the x's positive, but you don't have to do it that way. I'm going to add the 1 to the other side, and so that is going to be 4/3. Does that sound right? Okay, and if we wanted then to find the y-coordinate of the point of intersection, then we can plug that into either one. So I think this one looks pretty nice. So if we go y equals 4/3 minus 1, and thinking of the 1 as 3/3, that's going to be 1/3. Okay, so what if I now change the question? So instead of calling that the equations with the equal signs that we have right here, then what if I change it to, I want y greater than x minus 1, and y is less than or equal to the negative 2x plus 3. So how is that going to change the solutions? Here we had just one solution. There's one point that will lie on both of these lines that will make both of those equations equal to each other. If I switch these to inequalities, how does that change?
It's not just one point, it's multiple.
It's going to be lots of points. In fact, an infinite number of points. Okay, so how do we represent that? I can't write them all down. So how do we represent that infinite number of solutions?
A graph.
a graph is usually done. So we'll graph these. And the first one, we're going to have a slope of 1 and a y-intercept of -1. So I can go, there's the -1 for the y-intercept, rise 1, run 1. And the points on this line, because we chose a strict inequality here, are the points on the line going to be part of the solution set? No. So how do we show that? A dotted line. So I'm going to label the line itself is y equals x minus 1. And the values, the ordered pairs that have y coordinates greater than whatever that x minus 1 is, are they going to lie above or below this line? Above. Okay. So I'm going to shade here in a moment. Well, I can even shade kind of light here if I can. And then I'm going to do this one. So now we have a y-intercept of 3. So I'm going to go 1, 2, 3. And the slope here is -2. So we'll go down 2 over 1. And the points on this line, are they going to be included in the solution set or not?
Yes.
They are. And so I'm going to make this what kind of a line?
Solid.
Solid. Very good. And the solutions to this, the points in the plane that have the y coordinates less than or equal to whatever -2x plus 3 is, do they lie above or below the purple line? Below. So we're looking at this. And so the things, the solutions, all the ordered pairs that will solve both of those at the same time are going to be in that region that is shaded by both of those. And I'm going to try to make that stand out a little bit more. So I'll put it in the yellow color there. Okay? Okay. So consider, I'm going to give you a different system of equations here. So consider the system of equations of y is equal to 2 plus 0.3x and y is equal to 4 plus 0.25x. And I'm going to ask you the questions again. Will they intersect? And when you, I'm going to ask you to turn to your neighbor in a moment and discuss this. And I would like to know explain the role of M and B. So when you're making this decision, are they going to intersect or not? How does that M and B impact what's happening there? Okay, so take a moment. You can turn to somebody next to you, and you can tell, the first person can turn to the second and say, do you think they're going to intersect, and why? And then the second person can answer back. So in terms of the graph, what's M doing and what's B doing as you compare these two to each other? Okay, go ahead.
Oh, plus. 2 plus.
Sage Claire's waiting for somebody to talk to her. I can tell.
I mean, I do. Just look is different.
Taylor, I don't think anybody's talked to Claire at all today. Okay, so what's our conclusion? Are they going to intersect?
Yes.
Why? Yeah, they have different slopes again. So what, compared to each other now, what's the M and the B doing? Somebody that we haven't heard from for a while. Explain what this is in your interpretation.
It's still y equals mx plus b, but it's just m and x and b are just.
So the fact that this has a B of 2 and this has a B of 4, So as you look at the graph, what does that tell us? Where do they lie compared to each other? As they cross the y-axis.
The one with 4 is gonna be higher.
Yeah, so this one's going to start above this one. At least if we think starting as being where x is 0, where it crosses the y-axis. Okay, so you can see that the bottom one is going to start above the top one. And because of their slopes being what they are, then what's going to happen from that starting position?
They're gonna both go away from each other.
Okay, and how, in which way? They both have positive slopes, so they're both going to be rising from left to right.
But the
But
bottom equation will be rising slower.
good. So the bottom one is going to be rising faster than the lower one, right, because of the 0.3. So if these are going to intersect, in which quadrant are they going to intersect? You remember quadrants.
So that's the second.
You got it. 1, 2, 3, 4 are the quadrants. So which quadrant are they going to intersect in? Quadrant 1, right? Can we see that? I'm just trying to make you think a little bit harder about it. Good. So let's do an application here. So let's consider 3 rental car agencies. So we'll consider 3 rental car agencies. And their rates. So, and their rates. Where D is the number of miles driven, and C is the cost, and we're going to measure cost in dollars there. So D is going to be the number of miles you drive the car once you rent it, and C is going to be that cost. So we're going to say the first, I'm going to do these in different colors because I can. So our first agency is going to charge 0.50 D. Our second agency is going to charge 30 plus 0.2 D. And our third agency is going to charge 50 plus 0.10 D. So the first challenge is, can you explain the meaning of M and D? Explain the meaning in the context of this problem of M and D. M and D. So partnering up again, I would like the first person to turn to the second person and say what the M means in the context of these problems is, and then they will say whatever they think it is. And units are important here, so your explanation of what M represents should include whatever appropriate units that you would use. Then the second person can listen, and if you don't agree, you can have that discussion and try to resolve it. Then the second person will turn to the first person, explain what the B means, and again, units should be part of that explanation, and if you don't agree, you have to resolve it. Make sense? So you got to reach consensus here. You got to talk to somebody. Go.
I think the first are, and then you could use and now it's that's what different miles. Yeah. Yeah. Okay. And then yeah. What is the next thing? Yeah. Okay. Yeah. And then I think so. I guess it's not really. So I was the first yeah.
Okay, how are we doing? Still talking? That's fine. Okay, somebody we haven't heard from much today. Who wants to try to tackle the whole M business, this slope thing? What's in the context of this problem, trying to use correct units, what does M represent? Yeah,
Would it be how much it costs per mile driven?
yeah. So it's going to be, and that's exactly right, because the slope is going to be our units of the Y value, that's our cost in dollars, per the unit of the D, which is in miles. So this is representing the dollars per mile that we're going to have to pay. So you can see at a glance that, you know, the first agency is going to charge us kind of a premium, 50 cents per mile. The second one seems more reasonable, 20 cents per mile. And the third one is even a better deal, only 10 cents per mile. Okay, so how about the D, or the B rather? So somebody else want to explain what does the B mean?
Is it the starting cost?
Yeah, so in the case of this, it's how much we're going to get charged before we even drive it off the lot, right? So we sign the agreement, we're going to rent this car, we have the agreement on what we're going to pay for each mile that we drive it, but there's another cost that's going to be just upfront costs. So even if you never drive it out of the parking lot, you're going to have to pay $30 here and $50 here, but I guess you could sleep overnight in the car there at no cost because they're not going to charge you for it and you're not going to drive it. So that might be an option to think about. Hotel space is tough to find. Does that make sense? Okay, so then what we're going to do is graph these, and then we're going to try to answer the question, you know, which is going to be the better deal and when. Okay, but we're going to try to graph it first. So I've started my XY axis, but I'm going to say the miles driven is going to be on the horizontal, and the cost is going to be on the vertical. And if we graph this first one, then what I'm going to do, and I'm going to put 100 is going to be up here. So, and I'm going to do this rather than using slope and y-intercept, because this graph is going to get pretty big, and then if I'm off a little bit on the slope, then it's going to make me be way off by the time I get to the edge of the graph. I'm going to think of plotting points here. So if for the first one, we're charging 50 cents per mile driven, when we get to 200 miles driven, how much are we going, what's that point going to be? What is the cost?
$10.
Actually, I think it's 100, right? So we get, it's like,
0.5.
yeah, 0.5, so half of the 200. So this 200 is going to line up with the cost of 100, and if we don't drive it at all, it's going to be 0. And I know it's going to be a straight line, so this is going to be our C1. I'm trying to stay consistent with the color. You have to use your imagination in the whole straight line thing. So that's supposed to be a straight line. Don't judge me on that. So now we're going to do the second one. So let's see, at 0, we're going to be at 30. So here's my estimation skills. If that's 100, I think 50 is going to be like right about there. And so 30, I'm thinking is going to be right about there. So at 0, we're going to say that's 30. Now we get to the end at 200. Let's see, 0.2 times 200. 0.2 times 200 is going to be, see, one of the zeros will move the decimal over. I'm going to do this. So on 200, I can move the decimal over with one of those zeros. So that's really the same thing as 2 times 20. So that much is going to be 40. And then we still have the plus 30 is going to be 70. So my estimation skills, I'm going to say right about there is 70. And so at 200, we're going to be right in about there. So it started out more expensive, but if we drive it far enough, then this is going to be cheaper than the agency one. So we're going to see here that the best choice, the cheapest choice for us is going to depend, right, on how many miles we drive it. Okay, so on the third one, we're going to start at 50. So there's our the cost if we don't drive it at all. If we get out there to 200, 0.10 times 200 is going to be You don't like that? Did I not do that right?
1.
20, right? Because you can take one of the zeros and move the decimal over, so it's 1 times 20, plus the 50 is going to be 70 again. So it looks like by the time we get to driving 200 miles, C2, Agency 2, and Agency 3 are going to cost us the same. So there's going to be Agency 3. Okay, so far? All right, now let me see if I can ask some questions. Let's say, first one is, for what distance does Agency 1 and cost the same as Agency 2? For what distance does Agency 1 cost the same as Agency 2? So you can look and decide that. I'm going to ask all my questions so you can be chewing on them, and then we'll come back and try to resolve them. If you drive 50 miles or less, which option is your cheapest? We're all about saving money in our choices here. And the third one is, how do you decide which is the cheapest? So I want to know, under all conditions, how do you decide which is cheapest? Okay, so I'll give you a moment. See if you can answer those 3 questions. And if you can get it, the third one is going to maybe be dependent. So you're going to have to say, you know, if I drive this many miles, then I'm going to choose this agency. But if I drive between this many miles and this many miles, I'm going to pick a different agency. And if I'm going to tour the country, then I'm going to choose whatever agency. Does that make sense? Discussion, collaboration is encouraged. Try to keep your voices low so it doesn't get too loud in here. You're socially distanced, so whispering isn't going to work here.
I think it's well, depending on the situation. I'll just see the cheapest one around the normal. And then 2 is the cheapest. I got from 100 to 200. Okay. I didn't know. Did you do the 50? Are you talking about the second question? Oh, I'm talking about the number 3. Just which one would be cheapest, like, okay, depending on the situation. Yeah, okay. Yeah, like, third one, you have to drive a lot for it to be cheaper for over 200 miles. That's not a hard one. Yeah. It's like driving past the black hole. But if you're only driving a little bit, you probably get the first one. Yeah. It's a very difficult problem.
So let's talk a little bit. How about the first one? So what distance do they end up costing the same?
100 miles.
Yeah, right, and you can see that here. You can see it visually right here because Agency 1 is the green line, Agency 2 is the pink line. You can see it algebraically. If you set these equal to each other, then you're going to end up with the 100. So you can also see visually, which is kind of nice, that since the green line is below the pink line to the left, that agency 1 is going to be cheaper if we drive under 100 miles. But once we get above 100 miles, agency 2 is now going to become cheaper than agency 1. So that's kind of the way to read that, hopefully. Good. And if you drive 50 miles or less, then which is the best deal? So it's the line that's closest to the x-axis. And so that's going to be agency 1. Does that make sense? And then how do you decide which is the cheapest? This is kind of the question here that gets to the heart of things. So now you're going to have to, the hard part, I think, if you're really doing this for real is, do you know how many miles you're going to drive? Sometimes you may not know that, but probably you have some idea anyway what your use is going to be. So the cheapest then is between 0 and 100 is going to be this green line, right? So agency 1 is going to be the cheapest if you drive between how many miles and how many miles. Yeah, and we could, I think, say we can include the 0 and the 100. So at 100, it's a coin flip, right, about which is going to be cheapest. But you can put them in either case there. So then once you get to 100 miles, now again, what we're doing is trying to follow the path that's closest to the x-axis. So now we're going to jump to that pink line, which is agency 2. And so agency 2 becomes the cheapest. And we can include the 100 there. Again, like we said, that's going to be a coin flip. So which one's got nicer cars, I guess, might come into play there. And this is going to be the cheapest up until when? Till we drive 200 miles. Okay, and so that's going to go to 200. Then if you're going to really be a road warrior and get on there and drive, then if you're going to drive a lot of miles, a lot being more than 200, then your cheapest is going to be agency 3. And so agency 3 is going to be for anything more than 200 miles. Questions on that? Okay, so I'm going to change gears here. This is what I wanted to do kind of for the new material. I want to come back and do some more with this whole difference quotient thing, because these are going to be important problems, and I know they can be challenging. So we're going to talk more about that difference quotient. And so what we're calling the difference quotient is really just our complicated way of saying slope formula, average rate of change. So I'm going to start with one with just numbers, and then I'm going to quickly go to doing ones that are more abstract. So I'm going to say f of x is equal to 3 minus x squared. And can we find the average rate of change, which I'm going to just call ROC, the average rate of change between x equals 2 and x equals 5. What are we doing? Should we do this at the board? Let me do this one with you here because I want to get to the more complicated ones. It takes a little bit longer. So help me here. What are we going to start? So tell me symbolically, using function notation, before we actually plug in the numbers, what are we going to do? Do you understand what I'm asking you? So if I think of this as the A and this as the B, one way that we have this rate of change is we said that it's f of B minus f of A all over B minus A. So using the same functional notation, but now plugging in the correct numbers for A and B, what is our rate of change going to look like? So what's f of B?
The outcome if you plug in 2.
Yeah, and I'm gonna go with the bigger number, but you could do it either way because then I'm going to try to choose where the B minus A is going to be positive. But you could do it either way.
Okay.
So you're going to get the same result. You just have more negatives to keep track of, and sometimes that opens the door to more possible arithmetic errors. So I'm going to say f of 5. This is what I was looking for, minus f of 2. So I'm just trying to get you to think in terms of this functional notation, because I'm going to go from numbers to the x's and x plus h's here in a moment, but I want to kind of plant this seed in your brain of how we're doing this. Then we can plug it in. So what is f of 5? Well, you're going to take 5, square it, and then go 3 minus that.
Negative 22.
So 3 minus 25, so I'm going to write it out here. So 3 minus 25, and then I'll come back and simplify that. And then we're going to subtract from that the 3 minus 2 squared, which is the 4, and we know the 5 minus 2 is 3 on the bottom. You with me here? I need nods of heads. Okay? And so then we're going to get on top the 3 minus 25, Nora said was a negative 22, and we're going to get a minus negative 1, which is going to become plus 1, and that's all over 3. So negative 22 plus 1, I guess, is negative 21, divided by 3 is going to be a negative 7. Okay, so that's the idea with numbers, but I'm trying to introduce this idea of functional notation. So the big thing that we are trying to get to is, can we find that rate of change? Same function, but this time we're going to say between x comma f of x and x plus h comma f of x plus h. And this is where it gets more interesting. Okay, and this is going to be our problem that we're going to see over and over and over again. I like to refer to it as our favorite problem. Maybe not yet, but we're getting there. So the challenge here is f of x plus h. So remember, we're going to plug x plus h in where we see x. So that's going to look like 3 minus, and in the place of that x, I'm going to plug in the x plus h and then square it. You okay so far? Any nods of heads? Good. So you holler when I start to lose you or go too fast. Minus. Now I'm going to subtract off the whole quantity f of x. And f of x is this whole thing, the 3 minus x squared. Notice that minus is going to have to distribute over this. This is an easy place to make a mistake. All over x plus h minus x. I'm going to write it out here, but we can soon skip that step because we're going to get the same result every time. Okay, we talked about briefly our shortcut for squaring out a binomial. Do you remember it? Can you say it with me? We said it is the first one squared, hello, hello. The first one squared twice the product plus the second one squared. I'll give you another chance at that, saying it the same together part. Ready? It's the first one squared twice the product plus the second one squared. That was much better. So that we have the 3 minus, the first one squared is going to be, good, twice the product is going to be 2x plus a 2xh. And the second one squared is going to be h squared. And I'm going to go ahead and distribute this negative sign and go a minus 3, a plus x squared, and the x plus h minus the x leaves us with just h in the denominator. Okay, I'm going to clear off space because I'm going to work my way up now. So we're going to distribute that negative sign. So we've got 3 minus x squared minus 2xh minus h squared. We still have the minus 3 and the plus x squared all over h. I love doing that all over h part. Okay. Now anything that does not, if we're doing this right, this is kind of a check at this point in time. If we're doing this right, always anything that doesn't have an h in it is going to cancel with something else. So let's see. We have a 3 here and a minus 3 there that don't have h's. As promised, they're going to cancel. We have a minus x squared here and a plus x squared that don't have h's. They are going to kill each other off. Everything else has an h in it. Okay so far? So I'm just going to rewrite that for a minute. So we have a negative 2xh minus h squared all over h. Now the next step is how you know you're going to finish, because this will always happen. We're going to factor an h out of the numerator so that we can cancel it with the h in the denominator. And when you factor out the h, what is left behind is going to be, very good, negative 2x minus h. And then finally, this is where it ends, is when we cancel those h's, and our final result is, in this case, the negative 2x minus h. Crazy fun. I think we should do one at the board. Whose turn is it? Everybody's touching their nose. So let's change the function to make it even harder. Maybe. Let's go x squared minus 3x plus 5. And we are going to find the average rate of change, which is going to be our difference quotient, f of x plus h minus f of x all over h. Whoever has a pen or marker that wasn't the last up at the board is now up at the board doing this. Go, 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 go. Oh, it's an honor check here. I know there are more people up at the board than that. So Ashland's being shamed to the board here, huh? Certainly there was somebody at the chalkboard, wasn't there? Oh, can you slide over? Somebody slide over? I guess we're gonna social distance. I thought you were just up there. Is that what you thought too? Oh well. Go ahead, you do it. Need an example. I'm gonna give you a head start and then I'm gonna jump in.
Oh, no.
Oh no, it's a race. Just kidding. F of x plus h minus f of x all over h.
So much harder than the first one.
Ah, I usually do the easy ones myself and leave the harder ones for you. It's a strategy.
We just stay in the house and figure it out.
So everywhere you see an x, we're going to throw in an x plus h.
I got it now.
Now we're on a roll.
Now we're on the right
Getting
track.
started is the hard part,
Yes.
usually. To use our shortcut again, first one squared twice the product plus second one squared. Or you could multiply out x plus h until you get tired of doing that. And provide motivation for learning the shortcut. So this is the multiplying out. That came from there. And then that led to this stuff. And then we just distributed,
What's the?
and we just distributed the minus sign over the second one. Question? You read that okay? Oh! Doggone it. See if I can do this real quick. X squared, 3x, 5. So we're going to get 2xh plus h squared minus 3h all over h. Factors cancel. So we're trying to get to 2x plus h minus 3.
Yeah, I got, where do I go? Yeah, and.
So there's baskets on the side, so you can put your used markers there, and I'll sanitize them.
Oh, look, I think I got it right.
You want us to erase it?
Yeah, that'd be great. Saves me doing it. Did you get it?
Oh, I get it now. Where did I mark the right there? What do you want?
All of them.
Nora, have I had all your siblings so far? Do you have a
I think
bunch
so.
of older siblings?
I only have two, but
Yeah, two.
Yeah.
I've had both of them, yep.
a lot.
Well, how we doing, guys? Okay? All right, thanks, you too.